Hey everybody, this is Larry. This is me doing week 3 of the March weekly premium challenge. Forgot to do it yesterday, so hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. This one is going to be 253 Meeting Rooms 2, a classic problem. Seems like I've solved this. Is there no like solved indicator? I guess I have solved this. Oh well. I'm on the old UI because the new UI is kind of crap. So yeah. 253 meeting rooms 2. Given a way to the start and end, return the minimum number of conference room required. A little bit shorter in detail, but yeah, I assume they mean like the maximum, because yeah, the maximum overlaps is where you have, is where you have the most rooms needed. So that's basically the way that you would do it, to just calculate the number of overlaps. I want to try something new. Usually, and I think this was only a year ago, so I already have the solution that I usually do, which is event sorting and doing it that way, which I super recommend. But I want to try something new. To introduce to you. If you haven't seen it already, if you've seen it already, that's okay. So the first thing we want to do is kind of look at the constraints, right? Yeah, the constraint is 10 to the 4th, but the number is 10 to the 6th here. What can we do? Well, one thing we can do is what we call normalization, or coordinates compression, or coordinates normalization, depending on who you ask, or something like this, right? But basically, you can think about each, is a one, and for this case, it's a 1D timeline. You have an X or T, I guess if we're calling timeline, but you have a T, and then here, it really doesn't matter that it's between 5 and 10, as long as there's nothing in between 5 and 10, right? So then now we can compress the coordinates so that, all the you can think about it visually as we have all these intervals, and we kind of remove all the spaces in between. So then now in this case, because there are two numbers here, it can only go up to 10 to the 4th, because they're at most 10 to the 4th unique coordinates, right? Times 2, because one for beginning, one for the end. So that makes it just like a smaller bound, so we don't have to deal with 10 to the 6th. Why do we want to do that? We'll get to it, but let's do that first. So yeah, for start and end in intervals, right? So then now, usually we would have something like a set. So maybe like a, I don't know, C for coordinates, something like this. That should be fine. And then we just C dot S, C dot add E, right? And this will be a set, right? And then now we want to, take it out now for sorted. We want the index of the order X in enumerated, if I could say that right. Right, and then now we just map every X. So now you have two things, right? You could maybe want an array, and then also the reverse lookup. And then now coordinates, we can append just X. I guess we could have just done it another way, but whatever, right? And this is all lookup is equal to index. So that's basically, now this pair allows us to kind of map every number here into, like I said, a number from 0 to 1 to 10 to the, or to like 2 times n. And then reverse lookup allows us to kind of do that mapping, and coordinates let us do the reverse mapping, or depending how reverse of the reverse mapping, I don't know, something like this, right? Depending on what you need. So yeah, okay. So that's basically the initial idea. And the reason why we do this is that now we can actually use something kind of and this is kind of on topic for what we've been doing the last week, both on the daily problems the last couple of days, and also like one problem yesterday for whatever reason, which is prefix sum, right? So the idea with prefix sum with this one is that you can represent an interval at the starting point as +1 and then the ending point is -1. So then now, as a prefix sum, everything in between will be filled in, right? So that's basically the idea. And now you could do this again, right? We have S and Y, So what is S and U? Well, S lookup of S. So then here, oh, I forgot the prefix sum. So prefix sum is going to be equal to 0 times, now it's just going to be the length of coordinates, or C, I guess, doesn't matter, times 2, right? Because that's the max element. And then now the reverse lookup, we could do prefix from the beginning. We could do add 1, and then we can do the n minus 1. We have to be really careful about how we want to define it, because it depends on how you define the inclusive and exclusive bounds. I like it so that it is inclusive on the left and exclusive on the right, so that I could write this, so that all lookup, they mix it so that all lookup sub y, that index contains the +1. So yeah, so that's why I did it this way. And then now that you have all the prefix sum set up, we can just do the prefix sum, right? So now for I in range of length of prefix, maybe my well, from 1 to length of prefix, and then here prefix sub I, just add prefix sub I minus 1. So then now this is a prefix, because before you just have all the individual sums. Now you could make it into a prefix sum, right? And now that we have this prefix sum, what happens? Well, now we can get the maximum element, because the maximum element is going to be the element with the most overlap, right? Because if you think about an interval, maybe I should have joined this. But if you think about an interval as having 1, 1, 1, 1, 1, 1, 1, 1, and then another 1, 1, 1, 1, so then we sum it up, it'll be 2. Maybe I should just draw it. Hang on, I'll just draw it. Maybe it's a little bit late, but you know what they say, better late than never. So I'll kind of explain the concept a little bit again, but it's kind of cool. So if not, you could fast forward. I don't know. Yeah. All right. So basically, the idea is that the path or the coordinate compression. Let's say you have, and I'm going to sort them just for laziness here, like 8, 10, 12, or something like this. And then the idea with compression is that you get rid of this space in between. So then now it's 1, 2, 3, 4, 5. That's basically the idea. And so that's the idea of the coordinate compression. And then the idea of prefix sum is that, okay, let's say, and I just added a 6. Let's say you have a segment from here, you have an interval from here, and then you have an interval from here, right? So then the idea here is that to represent this interval, you can say that, you could just say that this 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, right? Of course, if you actually do it that way with a for loop, it will take too much time, because, for example, if you just have 1,000 cases of 1 to 6 or whatever, then it will just time out or whatever, right? So then the idea here with the prefix sum is that now we're just saying at 2 plus 1, and then at between 4 and 5 minus 1, right? So same here, plus 1 minus 1, plus 1 minus 1. And then that's where the prefix sum comes in, is that now it knows that it's going to be plus 1 entire way, and it carries all the prefix. And also now, if you kind of add it vertically, now you have 1, 2, 3, 3, 2, 1. So then now the max is going to have 3 overlaps, which is what we're looking for. So that's basically kind of, maybe I went a little bit fast. Definitely let me know in the comments, but that's basically the idea. And then now we can return max of prefix, just to max them, and we should be good. Yeah, and I don't remember to use quick one example cases. Oh snap. Did I misunderstood this? Maybe I misunderstood this. I mean, it's fine. It's an easy fix. That's where this part came in. I wasn't sure if this would overlap. That's why I probably should have tested it. That's my fault. But I was thinking does this overlap? But then I just kind of forgot about it because I've just been very sloppy these days. But yeah, now that we know that these don't overlap, it's an easy fix. We just have to kind of do this because it doesn't. So then now at 13, you get out the woman. You just don't sum it. So yeah, pretty straightforward fix, as you can see. Consistency is key. But yeah, it's just depending on the interpretation. I should have tested and checked this, or at least think about it. I thought about it, and I thought maybe they overlap, but I guess technically not. I don't know why I thought that, to be frank. But yeah. Anyway, so this is going to be linear time, linear space for this the coordinate compression, and everything else, as you can see, is just linear time, linear space. So the entire thing is going to be linear time, linear space, which technically speaking is faster than n log n1. So depending on how you know, how you want to think about it. And you probably could just check out that video in case you want to, because that was only last year. So I mean, the code is pretty straightforward in both cases once you understand the ideas. The ideas are the hard part, right? But yeah, that's all I have for this one. Let me know what you think. Maybe I'm going a little bit fast, but stay good. Leave me a comment if that is the case. Let me know your questions, not your confusions. But yeah, stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.